Now, I know that was a lot, but guys, chemistry requires a lot of steps, okay? It requires a lot of steps. So we're going to do another one, okay? We're going to do another one. And this one, excuse me, right here, deals with solving for activation energy. Now you're going to have to use the formula for E of A. Now, let me show you all the traditional formula you would see for activation energy. You normally would see this one right here. The natural log of K equals the natural log of A minus E of A over R times T. All right. Yes, you do that first. Exactly. Yep, you do that first. Now, in this case right here, I'm going to color code what you see so that way you will know what you're working with. And remember, your gas constant, matter of fact, I'm going to go ahead and I'm going to take the R from up here so that you all know to use this each and every time, okay? Because you're going to need that for this problem right here. So if they don't give it to you, just know that you have to have it to solve the problem, okay? Now, what you're going to do is color code, or at least that's what I would do. I color code so I know what numbers go where. So to start off, you have the temperature, 298 Kelvin. That's going to be this number on the very bottom. They give you the K, which is your rate constant. But let me ask you this. Do you see this anywhere here? Yes. Here's your K right there. Then you're going to have the next one, which is your frequency right here. And then your R right there goes right there. So what are you looking for? I'm going to highlight it in purple. You're looking for the activation energy. Okay, that's what you're looking for. So what I'm going to do to make this easy, we're going to plug in the numbers because technically speaking, I could rearrange this formula and have you all figure out what E of A is equal to. But I'm going to go ahead and plug in the numbers to make it a lot simpler for you to digest. What's going on? Definitely not Maria. I'm working on that video for you, and I'll have your response this afternoon, my video response for you. All right, so what are you going to do right here? You're welcome. I'm going to plug in, you see where it says natural log of K, right? I'm going to say natural log 1.5. Look at me putting the wrong number. Natural log of 1.5 times 10 to the negative third per seconds equals natural log of A, which was your frequency, natural log 5.0 times 10 to the 10th per seconds minus, you're looking for your E of A, so that's on the top, divided by your R, your gas constant, 8.314 joules per moles dot Kelvin. Yes, you want to put those units. Divided by your temperature, 298 Kelvin. All right, we're going to go ahead and get rid of the units that we don't need right here. We don't need the Kelvin, so we slash those. All right, now, let's go ahead and find out what is the natural log of 1.5 times 10 to the negative third equal to, and what is the natural log of 5.0 times 10 to the 10th, and what are these two numbers right here multiplied to get you. All right, we're going to do all of that right now. So I'm going to plug it into my calculator. All right. So right here on my calculator, again, I can't tell you about yours unless you tell me what kind you got, but I would have to see it. But on mine, I have to put in the number first, 1.5 times 10 to the negative third. See that? Then I'm going to hit this natural log button. Nope, that's not it right there. Hold on. 1.5 times 10 to the negative third. And I'm going to hit this natural log button. Negative 6.50, okay? Negative 6.50. So that's this one right here, negative 6.50 equals. Now let's get to the natural log of 5.0 times 10 to the 10th. See that right there? And then the natural log, and I get right here 24.63. Notice this is not negative, it's positive. 24.6. And I got to put those units there. Let me be consistent with my units, okay? Because just like I'm telling you all, to be consistent, I need to also do the same thing. Now, minus your E of A is what you're looking for. That's on top. Go ahead and multiply the two numbers on the very bottom. So 8.314 times 298. That gives me 2477.5. But we're just going to say 2478. So 2478 joules per mole. Okay, that's that unit. Okay. Now, and again, right here, y'all, this is just basically going to be basic math now at this point. Now, why do I say basic math? Because you're going to take this 24.6. I'm going to add it to both sides so that I can get rid of that one right there. I'm sorry, subtract, because it's already positive over here. My bad, y'all. I'm subtracting 24 from both sides. So I got rid of that part right there, okay? So 6.50 negative minus the 24.6 gives us negative 31.1 per second equals negative E of A divided by 2478 joules per mole. Hey, Chris, you said, will we only use Arrhenius equations when there's two temperatures given? No, I mean, you use Arrhenius equations for a lot of different things. You can use it for finding the frequency. You can use it to find one of the temperatures. You can also use it to find the activation energy or even the K rate constant. All right, now the last step of this, guys, is to multiply. You're going to multiply those two right there, including that negative sign, so that you can get E of A by itself. Again, you're going to multiply these two, including the negative sign, so that the two negatives can cancel out. All right, so to get your E of A, your activation energy, you're going to say negative 31.1 per second times 2478 joules per mole, okay? Which was also negative. And that gives you your answer, okay? But anytime you have those natural logs, guess what? The unit cancels out, okay? Anytime you have those natural logs, the units cancel out. So now you're left with multiplying this part right here, okay? You're going to multiply those two numbers together, and then you will end up with your answer, okay? So let's go ahead and plug this in right here. Negative 31.1 times negative 2477, and I get a big number. My activation energy is equal to 77,034 joules per mole. And just like that, we are done with that problem. Okay, we are done. I'm going to take this back from the top again so that we can see how we solve this problem. Because again, some of you all may have just stepped in while we were in the middle of doing it, and you're like, what the heck? Okay, so here's the problem. We were given the temperature, we were given the rate constant, the frequency factor, and the gas constant. We were solving for the activation energy. We color-coded to know where the numbers needed to go within our problem. I solved for the natural log of K and the natural log of A. I got those two numbers right there. Then I also multiplied these two numbers so I could get that number right there on the bottom. After I did that, I subtracted the negative 24.6 from both sides so that this can cancel out, and we're left with those two, adding those together, which ends up being a negative sign there. When you take two negatives, you end up adding them. You get 31.1 per seconds. But when you're doing the natural log, guess what? Those units disappear. And when the unit disappears, you're left with multiplying. See, you're looking for the E of A. So you multiply the 31.1 times 2478. And just like that, here's your E of A. Your activation energy equals 77,034 joules per mole. Let's go ahead and do the next one, number 3, which is a temperature problem, okay? So again, if you all know that you're given these problems, right, and you have to solve for certain things, why don't you go ahead and put the formula on your formula card so that you don't have to go through all the derivations of them? That would make life a little easier. Okay, that's what I would do.